This question is to determine the inverse of a transformed function. Suppose f of x is a one-to-one function. What is the formula for the inverse of the function g of x, defined as f of open parenthesis x plus c close parenthesis? First step is to understanding the transformation. When we add c inside the parentheses of function, as an f of open parenthesis x plus c close parenthesis, it shifts the entire graph of f to the left by c units. In other words, if the point open parenthesis a, b close parenthesis lies on the graph of f, then the point open parenthesis a minus c, b close parenthesis lies on the graph of g. Next step is to connecting the transformed point to the inverse. From a previous step, if g of open parenthesis a minus c close parenthesis equals b, that means the inverse of g, evaluated at b, must be a minus c. But since f of a equals b, we also know that the inverse of f, evaluated at b, is a. Therefore, we conclude that the inverse of g, evaluated at x, must equal the inverse of f, evaluated at x, and then subtract c. Next step is to final conclusion. Putting it all together, the inverse function of g is equal to the inverse of f minus c. That is, g inverse of x equals f inverse of x, then subtract c. A common misunderstanding is to assume that if the original function shifts left by c units, then the inverse should shift the input in the same way, for example, by evaluating f inverse at x plus c. That is incorrect. The shift is in the opposite direction for the inverse. To find the inverse of a transformed function, always think about how to undo each step. Work backward from the output to reverse the operations in the correct order. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to prove trigonometric identities. A step-by-step guide. First, recognize compound angle identities. We begin by rewriting the left-hand side of the equation using angle addition formulas. Cosine of 4x is rewritten as cosine of 2x plus 2x, which becomes cosine squared of 2x minus sine squared of 2x. Then we rewrite cosine of 3x as cosine of 2x plus x, which expands into cosine of 2x times cosine of x, minus sine of 2x times sine of x. Multiplying this by cosine of x gives us cosine of 2x times cosine squared of x, minus sine of 2x times sine of x times cosine of x. Next step is to expand using trigonometric identities. Now we write out all the terms we just described. Cosine of 4x becomes cosine squared of 2x minus sine squared of 2x. The second part, cosine of 3x times cosine of x, becomes cosine of 2x times cosine squared of x, minus sine of 2x times sine of x times cosine of x. So the full expression becomes cosine squared of 2x minus sine squared of 2x minus cosine of 2x times cosine squared of x, plus sine of 2x times sine of x times cosine of x. Next step is to use double angle identities. We now substitute standard formulas for double angles. Cosine of 2x is replaced with cosine squared of x minus sine squared of x. Sine of 2x becomes 2 times sine of x times cosine of x. Now let's evaluate each part. Cosine squared of 2x becomes the square of cosine squared of x minus sine squared of x, which equals cosine to the fourth power of x, minus 2 times cosine squared x times sine squared x, plus sine to the fourth power of x. Sine squared of 2x becomes 4 times cosine squared x times sine squared x. Cosine of 2x times cosine squared x becomes cosine to the fourth power of x, minus cosine squared x times sine squared x. Sine of 2x times sine x times cosine x becomes 2 times sine squared x times cosine squared x. Next step is to combine like terms. Now we combine everything together. Start with cosine to the fourth power of x, minus 2 times cosine squared x times sine squared x, plus sine to the fourth power of x. Then subtract 4 times cosine squared x times sine squared x. Next subtract cosine to the fourth power of x, and add cosine squared x times sine squared x. Then finally add 2 times sine squared x times cosine squared x. Now simplify. The cosine to the fourth power terms cancel out. The combined terms give us sine to the fourth power of x, minus 4 times cosine squared x times sine squared x, plus cosine squared x times sine squared x. This simplifies to sine squared x times the sum of sine squared x and cosine squared x, minus 4 times cosine squared x times sine squared x. Because sine squared x plus cosine squared x equals 1, this becomes just sine squared x, minus 4 times cosine squared x times sine squared x, which exactly matches the right-hand side of the original identity. The identity is proven. When working with expressions involving multiple angles, Always rewrite everything using standard double angle or sum angle formulas first. It helps simplify the problem early on and avoids mistakes later. Watch out for sign errors when expanding squares. Those are easy to miss, but make a big difference. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to solve exponential functions with a logarithmic approach. First step is to plug into the function. We are told that the function f of x equals a raised to the power of x minus 1/2. We also know that f of log base 10 of it equals the square root of 10. Now substitute log base 10 of it into the function. That gives us f of log base 10 of it equals a raised to the power of log base 10 of a minus 1/2. And this equals the square root of 10. Next step is to apply logarithms to both sides. Take the base 10 logarithm of both sides of the equation. On the left side, we take the log of a raised to the power of log base 10 of a minus 1/2, which is equal to log base 10 of a minus 1/2 multiplied by log base 10 of a. On the right-hand side, the log of the square root of 10 is 1/2. So we now have log base 10 of a minus 1/2 multiplied by log base 10 of a equals 1/2. Next step is to form a quadratic equation. Now let's simplify. Let x represent log base 10 of a. So we rewrite the equation as x minus 1/2 times x equals 1/2. That becomes x squared minus 1/2 x equals 1/2. Now multiply the entire equation by 2 to eliminate fractions. We get 2x squared minus x minus 1 equals 0. Next step is to solve the quadratic. We solve the quadratic equation 2x squared minus x minus 1 equals 0 using the quadratic formula. This gives us x equals 1 plus or minus the square root of 9, all divided by 4. The square root of 9 is 3. So we have two possibilities. X equals 1 plus 3 over 4, which simplifies to 1. Or x equals 1 minus 3 over 4, which simplifies to negative 1/2. Next step is to back substitute to find a. Now we recall that x stands for log base 10 of a. So if x equals 1, then it equals 10. If x equals negative 1/2, then it equals 10 raised to the power of negative 1/2. Final answer is either 10 or 10 to the power of negative 1/2. Whenever variables appear in the exponent, especially when you're given a value of the function, try taking logarithms early. It often turns messy exponents into clean, solvable equations. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to involve a triangle and an algebraic expression for one of its angles. In triangle ABC, angle A is the smallest interior angle, and you're told that the cosine of angle A equals the fraction where the numerator is a +1 and the denominator is a -1. Based on this information, determine the possible values that the real number can take. First step is to understand the geometry. Because angle A is the smallest angle in triangle ABC and the triangle is not equilateral, the measure of angle A must be greater than 0 degrees and less than 60 degrees. This tells us that the cosine of angle A lies between 1/2 and 1. That is, the cosine is more than 1/2 but less than 1. Next step is to use the cosine expression. We are given that the cosine of angle A is equal to the fraction a +1 over a -1. So, we now need to find all real numbers as such that this fraction lies between 1/2 and 1. In other words, we want to find all where a +1 over a -1 is greater than 1/2 and less than 1. Next step is to solve the double inequality. We will solve the two parts of this inequality separately. First, let's consider the condition that a +1 over a -1 is less than 1. To solve this, think about multiplying both sides by a -1. But be careful. The sign of a -1 affects the inequality direction. If a -1 is positive, then the inequality would not hold because it leads to a contradiction. So a -1 must be negative, which means that it is less than 1. Now let's take the second part. A +1 over a -1 is greater than 1/2. Again, we multiply both sides by a -1. Since a -1 is negative, we must flip the direction of the inequality. That gives us a +1 is less than 1/2 of a -1. Working this out, a +1 is less than 1/2 a -1/2. Now subtract 1/2 from both sides to get 1/2 is less than -3/2. Multiplying both sides by 2 gives you is less than -3. Combining what we have from both parts, a must be less than 1, and also a must be less than -3. The stronger of these is the second one. So, The final result is a must be less than -3. When working with inequalities that involve fractions, always check the sign of the denominator first. If it's negative, then remember to reverse the inequality when you multiply across. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to determine the equation of a parabola. Please subscribe to our YouTube channel Math Tutor 8285. Your subscription fuels the passion. Let's grow together. Thank you so much. A parabola crosses the x-axis at the points where x equals -3 and x equals 5. If the point where x equals 1 and y equals -16 lies on the parabola, what is the equation of the parabola? First step is to use x-intercepts to write the factored form. We're given that the parabola crosses the x-axis at x equals -3 and x equals 5. That tells us that the factors of the parabola are the quantity x plus 3 and the quantity x minus 5. So, we write the equation in factored form as y equals a times the quantity x plus 3 times the quantity x minus 5. Next step is to plug in the known point to solve for a. We know that the point 1, -16, is on the parabola. That means when x equals 1, y equals -16. Let's plug those into our equation. -16 equals a times the quantity 1 plus 3 times the quantity 1 minus 5. That simplifies to -16 equals a times 4 times -4. Multiplying those gives -16 equals -16 times a. Dividing both sides by -16, we find that it equals 1. Next step is to write the full equation in standard form. Now that we know a equals 1, we substitute that into our equation. So the equation becomes y equals the quantity x plus 3 times the quantity x minus 5. Let's expand this. First, x times x gives x squared. Next, x times -5 gives -5x. Then, 3 times x gives positive 3x. And finally, 3 times -5 gives -15. Combining the like terms, we get x squared minus 2x minus 15. So the final equation of the parabola is y equals x squared minus 2x minus 15. When you're given the x-intercepts and a point on the parabola, always start by writing the equation in factored form using the x-intercepts. Then plug in the extra point to find a, and finally expand the expression to get the full equation. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Your subscription fuels the passion. Let's grow together. Thank you so much. This question is to find how to solve for x, cosine, and absolute value. Determine all real values of x that satisfy the equation. The cosine of open parenthesis pi minus x close parenthesis equals the absolute value of cosine x. Choose from the following 4 options. Here, k is any integer. First step is to simplify the left-hand side. Using the identity that says the cosine of open parenthesis pi minus x close parenthesis is equal to the negative of cosine x. We rewrite the equation as negative cosine x equals the absolute value of cosine x. Next step is to solve the equation. This equation, negative cosine x equals absolute value of cosine x, can only be true when cosine x is less than 0. That's because the absolute value is always non-negative. So only when cosine x is negative will its negative equal its absolute value. Next step is to identify the interval for x. Cosine is negative when the angle lies in the second and third quadrants. That corresponds to x being between 2k pi plus 1/2 pi and 2k pi plus 3/2 pi, including both endpoints since the equation uses equality. Final answer is option C is correct. X is between 2k pi plus 1/2 pi and 2k pi plus 3/2 pi for any integer k. Always remember, cosine is negative in the second and third quadrants. So when solving equations that involve a negative cosine or absolute values, check where cosine becomes negative across one full rotation. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to determining the domain of a mathematical expression containing square roots and absolute values, ensuring it yields a valid real number. Which values of x make the expression the square root of 3 minus the absolute value of x, divided by the square root of the absolute value of 2 times x plus 1 minus 4, a valid real number? Option A, x is between -3 and 1.5, including -3, but not including 1.5. Option B, x is between -2.5 and 3, not including -2.5, but including 3. Option C, x is between -3 and -2.5, not including -2.5, or x is between 1.5 and 3, not including 1.5, but including 3. Option D, x is between negative 3 and 3, including both ends. First step is to understand what makes the expression meaningful. For the entire expression to make sense, first, the part under the square root in the numerator, which is 3 minus the absolute value of x, must be greater than or equal to 0. This tells us that the absolute value of x must be less than or equal to 3. Second, since the denominator is also under a square root and it's in the bottom of a fraction, we need the part under that square root to be strictly greater than 0. That part is the absolute value of 2 times x plus 1 minus 4. So, the absolute value of 2x plus 1 must be greater than 4. Next step is to solve these two requirements separately. From the first condition, the absolute value of x less than or equal to 3 tells us that x must be between negative 3 and positive 3, including both. From the second condition, we solve that the absolute value of 2x plus 1 is greater than 4. That happens when 2x plus 1 is less than negative 4, or when 2x plus 1 is greater than 4. Solving both, we find that x must be less than negative 2.5 or greater than 1.5. Next step is to combine the two conditions. Now we intersect both requirements. The first tells us x must be between negative 3 and 3. The second tells us x must either be less than negative 2.5 or greater than 1.5. So the final valid range for x is between negative 3 and negative 2.5, not including negative 2.5, or x is between 1.5 and 3, not including 1.5, but including 3. The correct answer is option C. When dealing with square roots and absolute values, always check the conditions separately. What must be non-negative or positive, then take the overlap of those conditions. That gives you the final valid range. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to determine the one-to-one function, which is essential for a function to possess an inverse. Which one of the following functions is one-to-one and therefore has an inverse? Option A, y equals sine of 2x. Option B, y equals the fraction with numerator 3x minus 1 and denominator x plus 2. Option C, y equals the logarithm base 5 of the quantity x minus 2. Option D, y equals negative 2x plus 7. Option E, y equals 2 raised to the x power minus 4. First step is to recall the key idea. A function is considered one-to-one if no horizontal line would touch its graph more than once. This is called the horizontal line test. If a horizontal line touches the graph in more than one place, it means the function gives the same output from different inputs and is not invertible. Next step is to analyze each option. Option A is y equals sine of 2x. The sine function repeats itself in cycles. Because of this repetition, the graph of sine will definitely be crossed by a horizontal line in many places. So, this function is not one-to-one. Option B is y equals the fraction with numerator 3x minus 1 and denominator x plus 2. This is a rational function. These kinds of functions often have asymptotes, but that doesn't automatically mean they are not one-to-one. However, to be cautious, we notice that it could still pass the horizontal line test depending on the behavior near the asymptotes. We'll revisit this if needed. Option C is y equals the logarithm base 5 of the quantity x minus 2. Logarithmic functions grow steadily and do not repeat. As x increases, y increases as well. So any horizontal line will intersect this graph only once. This is definitely a one-to-one function. Option D is y equals negative 2x plus 7. This is a linear function with a non-zero slope. All such functions pass both the vertical and horizontal line tests. So this one is also one-to-one. Option E is y equals 2 raised to the x power minus 4. This is an exponential function. Exponential functions either increase or decrease steadily, depending on the base. This one increases steadily. Since it never levels off or loops back, it passes the horizontal line test and is one-to-one. Next step is to eliminate and choose. Among the options, C, D, and E are all one-to-one, but we want the clearest and most straightforward choice. Option D, the linear function negative 2x plus 7, is always one-to-one with no ambiguity and no risk of confusion from asymptotes or domain restrictions. When you're unsure whether a function has an inverse, just imagine drawing horizontal lines across its graph. If any line touches the graph more than once, the function is not one-to-one, so it won't have an inverse. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to determine the domain of a composite function, specifically when the new function. Let the function f of x be defined only when x is greater than 0 and less than or equal to 1. Suppose is a real number between -1/2 and 0, including 0. Define a new function g of x as the product of f of x plus a and f of x minus a. The question is, what is the domain of g of x? First step is to understand what g of x needs. Since g of x includes f of x plus a and f of x minus a, both x plus a and x minus a must stay within the allowed range of f. That means x plus a must be greater than 0 and less than or equal to 1. And also x minus a must be greater than 0 and less than or equal to 1. Next step is to solve both conditions. From the first condition, x must be greater than -a and less than or equal to 1 minus a. From the second condition, x must be greater than a and less than or equal to 1 plus a. Next step is to take the overlap of both results. We now find the values of x that satisfy both conditions at once. That is, x must be greater than -a and at the same time greater than a. Also, x must be less than or equal to 1 plus a and also less than or equal to 1 minus a. Now, since it is between -1/2 and 0, it follows that it is smaller than -a and 1 plus is less than or equal to 1 minus a. So the overlap becomes x is greater than -a and less than or equal to 1 plus a. Final answer is that the domain of g of x is all x such that x is greater than -a and less than or equal to 1 plus a, as long as it is between -1/2 and 0, including 0. When a function includes shifted inputs like x plus or x minus a, always make sure those shifted values stay inside the original domain, and then take the overlap of the results to find the domain of the new function. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to calculate functional periodicity and domain constraints. Let the function f of x satisfy the condition that, for every real number x, f of the quantity x plus 1/2 equals 1/2 plus the square root of f of x minus the square of f of x. Find the period of the function f. First step is to analyze the functional rule. We are told that f of the quantity x plus 1/2 equals 1/2 plus the square root of f of x minus the square of f of x. For the square root to be defined as a real number, the part inside it must be greater than or equal to 0. So we set up the condition. F of x times the quantity 1 minus f of x must be greater than or equal to 0. This tells us that f of x must lie between 0 and 1, inclusive. In other words, the values of f of x are always at least 0 and at most 1. Next step is to apply the function rule a second time. Now apply the rule again, but this time to f of the quantity x plus 1. To do this, use the previous step and plug in f of the quantity x plus 1/2, which we already know is equal to 1/2 plus the square root of f of x minus the square of f of x. After simplifying the full expression, we eventually discover that f of the quantity x plus 1 is exactly equal to f of x. That means f repeats every 1 unit. So the period of the function f is 1. Be careful to check that the expression inside the square root is valid. It's a common mistake to ignore domain restrictions when roots are involved. When you see a function involving a square root, always test the domain first, then check whether repeated shifts in x reveal a pattern, especially signs of periodicity. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to simplify recursive function. Let the function f of x be defined as 1 minus the reciprocal of x. You're asked to find part A, the result of f composed with f of x. Part B, the result of f composed with f composed with f of x. First step is to find f composed with f of x. We begin by substituting f of x into itself. That means we replace x in the definition with the entire expression f of x. So we calculate 1 minus the reciprocal of f of x. Now recall that f of x is 1 minus the reciprocal of x. Therefore, we now have 1 minus the reciprocal of the expression 1 minus the reciprocal of x. To simplify that, we focus first on the inner fraction. The reciprocal of 1 minus the reciprocal of x becomes x divided by the quantity x minus 1. So the full expression becomes 1 minus x over the quantity x minus 1. Now we perform the subtraction. The numerator becomes x minus 1 minus x, which simplifies to -1. The denominator remains x minus 1. So the simplified result is -1 divided by the quantity x minus 1. That completes part A. Next step is to find f composed 3 times with x. Now we apply the function f again, but this time to the result we just found, which was -1 divided by the quantity x minus 1. That gives you s. F of that result, which is 1 minus the reciprocal of -1 divided by the quantity x minus 1. The reciprocal of that is negative of the quantity x minus 1. So the full expression becomes 1 plus x minus 1. That simplifies directly to x. So the final result is simply x. When working with composite functions, especially those involving fractions, speak through each substitution step clearly and simplify one layer at a time to avoid getting lost in the expressions. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to involve the transforming functions with variable substitution. Let the function f be defined for negative values of x by the rule that f of 1 divided by x equals x plus the square root of 1 plus x squared. Based on this definition, determine the value of x times f of x. First step is to make a substitution to simplify. We begin by letting t equal 1 divided by x. That means x equals 1 divided by t. Now, using the given definition, f of t becomes 1 divided by t plus the square root of 1 plus 1 divided by t plus 1 divided by t squared. Since x equals 1 over t, we can now write x times f of x as x multiplied by the quantity 1 divided by x plus the square root of 1 plus 1 divided by x plus 1 divided by x squared. Next step is to simplify the product. First, x times 1 over x simplifies to 1. Then, look at the second term, x times the square root of 1 plus 1 over x plus 1 over x squared. We can write that inside the square root as a single fraction. The numerator is x squared plus x plus 1, and the denominator is x squared. So the square root becomes the square root of that full fraction. Now, multiply x by that expression. You get x times the square root of the fraction whose numerator is x squared plus x plus 1, and whose denominator is x squared. That simplifies to the square root of x squared plus x plus 1, divided by the absolute value of x. But since x is negative, dividing by its absolute value flips the sign, so we end up with the negative of the square root of x squared plus x plus 1. Finally, we combine the two terms, 1 minus that square root. When a function is written in terms of 1 over x, try changing variables first. It often makes the expression easier to handle. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This question is to find the exact value of cosine of double theta. You're given that the cotangent of theta is -9 divided by 2, and that sine of theta is less than 0. Based on this information, find the exact value of cosine of double theta. Make sure your final answer is fully simplified and that any radicals in the denominator are rationalized. First step is to understand the identity. We're going to use the double angle identity for cosine. This identity says that cosine of double theta is equal to 1 minus 2 times the square of sine theta. Next step is to interpret what cotangent of theta means. Since cotangent is equal to adjacent over opposite, and we're told that cotangent of theta is -9 divided by 2, we can imagine a reference right triangle where the adjacent side is 9 units and the opposite side is 2 units. For now, we ignore the negative sign when solving for the triangle, because we'll apply the correct sign based on quadrant rules later. Next step is to use the Pythagorean theorem to find the hypotenuse. To find the hypotenuse of the triangle, we use the Pythagorean theorem. The hypotenuse is the square root of the sum of 9 squared plus 2 squared. That gives us the square root of 81 plus 4, which is the square root of 85. Next step is to determine sine of theta. From the triangle, sine of theta is the opposite side divided by the hypotenuse. So that's 2 divided by the square root of 85. But remember, sine of theta is less than 0, so the correct value is -2 divided by the square root of 85. Next step is to plug into the identity and simplify. We now use the identity from step 1. We square sine theta, which gives us 4 divided by 85. Multiply that by 2, and you get 8 divided by 85. Then subtract that from 1, which is the same as 85 divided by 85. 85 minus 8 gives 77. So the final answer is 77 divided by 85. When you're given a trig ratio and a condition like sine being negative, first build a triangle to find all the sides. Then use identities carefully and always check the sign using quadrant rules. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much. This new question is to determine how to divide complex numbers and express the result in standard form. Problem. Divide the complex number 2 plus 5i by the complex number 4 minus I and express the result in standard form, which means a plus bi, where a and b are real numbers. First step is to rewrite the expression as a single fraction. We begin by expressing the division of complex numbers as a single fraction. That is, place 2 plus 5i over 4 minus I. Next step is to multiply by the complex conjugate of the denominator. To simplify the expression, we multiply both the numerator and the denominator by the complex conjugate of the denominator. The conjugate of 4 minus I is 4 plus I. So, we multiply both the top and the bottom by 4 plus I. Red triangle pointed up. Common mistake alert. Some students forget to multiply both the numerator and the denominator. But remember, we're essentially multiplying by 1 in a clever form to simplify the expression. Next step is to multiply both the numerator and the denominator. Now let's expand both parts. Numerator. Multiply 2 plus 5i by 4 plus I. First, 2 times 4 equals 8. Outer, 2 times I equals 2i. Inner, 5i times 4 equals 20i. Last, 5i times I equals 5i squared. Now, combine everything. 8 plus 2i plus 20i plus 5i squared. Since I squared equals negative 1, replace 5i squared with negative 5. That gives us 8 plus 22i minus 5, which simplifies to 3 plus 22i. Denominator. Multiply 4 minus I by 4 plus I. First, 4 times 4 equals 16. Outer, 4 times I equals 4i. Inner, negative I times 4 equals negative 4i. Last, negative I times I equals negative I squared. Now combine. 16 plus 4i minus 4i minus I squared. The I terms cancel out. And since I squared equals negative 1, minus I squared becomes plus 1. So the denominator becomes 17. Next step is to simplify and write in standard form. Now take the simplified numerator, 3 plus 22i, and divide both parts by 17. This gives us the final answer, 3 over 17 plus 22 over 17i. When dividing complex numbers, always multiply by the conjugate of the denominator to eliminate the imaginary part and make the expression easier to simplify. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much.